Intro animation, flashing red map of Shanghai Pudong, Luzhui district. Text flash, crinkle constructural anomaly. Sound effect. Heartbeat monitor, beating rapidly, then flatling upbeat. Urgent cable news soundbite playing in the narrator. Look closely at the glittering skyline of one of mainland China's most prestigious financial hubs. Rising 204 meters into the humid coastal air, right along the high-value banks of the Huangpi River, stands a luxury residential megaproject that was supposed to be the crown jewel of elite waterfront living. A 60-story monolith designed to house 80 ultra-luxury sky mansions, with penthouses commanding a staggering 120 million yuan. But if you stand on the riverfront promenade today, you will notice something deeply unsettling. The glass panels are not catching the sunlight because they are being ripped off the facade. The tower is completely hollow, dead, and frozen. 71 wealthy buyers handed over massive life-altering deposits for a dream that has transformed into a concrete nightmare. For years, this ghost tower has stood completely abandoned, swaying violently in the typhoon-force winds pushing off the East China Sea. And it gets worse. This isn't just an unfinished skyscraper. The locals living in the shadow of this massive concrete hull have given it a terrifying nickname. They call it the Banana of Shanghai. Because this 204-meter tower is not straight. It is visibly, measurably bending, sound effect. Raring typhoon wind, underleaned by a heavy industrial drop-bass narrator. And the reason it is bent is the single most shocking engineering scandal in modern high-rise history. The curve in the concrete was not a structural accident. It was a deliberate, desperate choice made by engineers to cover up a catastrophic blunder happening underground. They tried to fix a sinking, leaning building by building the top half sideways. It failed completely. Welcome back to the Investigative Construction Files. If you watched our deep dives into the cracking residential towers of Shenzhen or the tilting foundations of the Tianjin megaprojects, you know exactly how the mechanics of greed operate in high-density urban planning. This is document number 4, the dossier on the infamous One Seaport Plaza development, marketed to elites as the pinnacle of riverfront luxury, developed by the prominent Huaxia Genesis Property Group, Graphic Fly-In. The cost of compromise. Site acquisition cost. 450 million yuan. Projected Kondok Mimimtal Selao, 1.9 billion yuan narrator. The blueprints were drafted by a top-tier municipal design institute. The structural calculations were handled by an elite global engineering consultancy. The exact same firm currently facing massive, multi-million yuan lawsuits over the notorious vibrating floor plates and cracking facades at a super-tall tower in Shenzhen. Construction was handed over to a massive state-aligned infrastructure corporation, and the excavators broke ground in the winter of 2015. But the path to a multi-billion yuan structural disaster does not begin in the sky. It begins deep in the dark, waterlogged soil of the Yangtze River Delta, where a single hidden financial cut completely doomed 204 meters of reinforced concrete before a single floor was ever poured. Sound effect. Metallic clanging reverberating. Deep underground narrator. Every structural engineer in China knows the unforgiving geography of coastal Shanghai. The bedrock beneath the financial district doesn't sit near the surface. It is buried deep, roughly 15 meters down, trapped beneath centuries of soft, highly compressible river silt, loose landfill, and water-saturated mud. For over 100 years, the golden rule of building tall on the Shanghai waterfront has been absolute and non-negotiable. You must drive deep, heavy steel, and concrete friction piles straight through that treacherous mud layer, hammering them directly into the solid bedrock below. When you anchor a skyscraper to bedrock, the building rests on the literal crust of the earth. Its settlement over 50 years is virtually zero. Look at any iconic super-tall surrounding this site. Every single one of them rests on heavy-driven piles anchored deep into rock. It is the mandatory engineering default, except at One Seaport Plaza, according to explosive legal filings later submitted by the general contractor. Huaxia Genesis Property Group looked at the massive budget required to drive hundreds of steel piles to bedrock and decided they wanted a discount. Instead of anchoring the tower to rock, the developer opted for an alternative. highly controversial method known in geotechnical engineering as soil improvement or jet grouting. 3D architectural satellite diagram. Animation showing the difference between pilsdriffen to rock vs jet grouting in silt narrator. Jet grouting involves drilling hollow tubes into the mud and pumping high-pressure liquid cement into the silt under extreme force, effectively churning the mud into a dense, semi-solid block of soil cement mixture. The developer's logic? Turn the mud into a stiff mattress and build the 60-story skyscraper right on top of that mattress without going all the way to the rock. The immediate payoff for this engineering gamble? Huaxia Genesis saved approximately 42 million yuan up front. That is a mere 2.2% of the overall projected project value. But here is the smoking gun. The specialized geotechnical firm that originally conducted the soil analysis for the site had issued a clear, urgent written brief to the developer before construction even began. The report stated explicitly that driving piles to bedrock was the only method guaranteed to eliminate structural settlement. They warned that a pile-driven foundation would make structural movement completely negligible. While soil improvement carried extreme risks in coastal river silt, the safe path was on paper. It was fully engineered. It was completely available. But the cheaper path is the one that got poured. And as the concrete began to rise floor by floor into the Shanghai site, the laws of physics came collecting on that 42 million yuan discount. Sound effect, a slow DEP. Ominous cracking sound under narrator. By 2018, the tower had reached its upper levels, its sleek, hyper-modern frame dominating the river view. But down in the basement, something catastrophic was happening. The high-pressure soil cement mattress under the northern edge of the massive concrete foundation mat began to yield, under the immense crushing weight of thousands of tons of curing concrete. The soft river silt compressed unevenly. The northern corner of the foundation mat sank faster than the southern corner. A microscopic shift at the baseline of a skyscraper does not stay microscopic. As that tiny, uneven settlement rippled upward through the vertical concrete columns, it multiplied exponentially with every single story. By the time the structural engineers pulled out their laser surveying equipment at the top of the tower, they discovered a terrifying reality. The luxury skyscraper was completely out of plumb. It was leaning over 76 millimeters directly to the north. To a layman, 76 millimeters across a 204 structure might sound like a drop in the ocean. You might think it's invisible to the naked eye, but in the unforgiving world of high-rise engineering, plumb is life or death. Skyscraper elevators are high-speed vertical vehicles. Their shafts must be perfectly straight lines. If the shaft leans, the cables scrape, the emergency brakes engage, and the elevator cars become unusable. The plumbing relies on gravity. An off-angle pipe creates catastrophic pressure backlogs. But the greatest danger of all was hanging on the exterior of the building, the glass curtain wall. Visual zoom, a graphic showing the enormous glass panels extending outward from an off-angle wall narrator. These multi-ton sheets of specialized exterior glass are fabricated to microscopic tolerances. They are designed to fit onto a structural concrete frame that is perfectly perpendicular to the earth. When the building tilts 76 millimeters out of alignment, the prefabricated steel anchor points no longer line up. The glass panels are forced into twisted, unengineered positions under massive structural stress they were never designed to endure, on a 60-story tower exposed to coastal storms. A glass panel that cannot be locked into its structural anchors is a ticking time bomb. It is a multi-hundred-kilogram sheet of razor-sharp projectile hanging hundreds of meters above a crowded municipal sidewalk. Huaxia Genesis was suddenly trapped in a multi-billion yuan crisis. If they stopped construction to completely underpin the foundation, it would bankrupt the project. So, someone made an executive decision that pushed this engineering disaster from a blunder into absolute absurdity. They decided to keep building upward, but they told the concrete crews to deliberately alter the angle of the upper floor plates. 3D mortal animation, showing the skyscraper curving in real time to counteract the lean, creating the despite banana-shaped narrator. The plan was simple on paper, yet completely insane in execution. To counteract the 76 millimeter lean to the north, They would construct the next 30 stories, leaning slightly to the south, attempting to bring the center of gravity back over the center of the base. They thought they could slalom their way out of a foundation failure. The result? The tower did not straighten out. The tower became a curve. It leans sharply to the north at the bottom and bends aggressively back to the south at the top. The deformation is now permanently baked into the reinforced concrete columns, structural shear walls, and floor slabs. It cannot be pulled straight. It cannot be pushed back. The structural skeleton of One Seaport Plaza is permanently, irrevocably warped like a piece of tropical fruit, and as the city looked up at this bizarre, bending silhouette on the skyline, the corporate cover-up began to completely unravel. If you want to track exactly how a single 42 million yuan boardroom compromise turns into a structural catastrophe that may require full urban demolition, and if you want to read document number 5 the exact day our investigation opens, hit that subscribe button right now. The pattern of corporate cutting is identical in every file, and this channel is built so you can audit them in chronological order. Stay tuned. The One Seaport file is only getting deeper. Sound effect. The sound of heavy machinery abruptly gritting to a halt, followed by the drifting echo of industrial, sirens over water graphic. A sequence of detailed engineering blueprints and survey maps dated from 2015 to 2020. Timestamps flash, in red in the corner of the screen narrator. To understand exactly how a premier riverfront real estate venture transforms into a multi-million-ton monument of structural deformation, we have to look directly at the engineering logs. We must trace the precise physical timeline where early warning signs were actively buried beneath thousands of cubic meters of pouring concrete. The structural failure of One Seaport Plaza was not a sudden, unpredictable act of God. It was a slow-motion, mathematical inevitability that was documented in real time, millimeter by painful millimeter. Let's go back to the spring of 2015, when the Huaxia Genesis Property Group officially initiated the excavation phase along the Huangpi River. Visual, archival footage of excavators and mud pumps churning through saturated, gray river silt narrator. The project design called for a massive, high-strength concrete foundation mat, a raft slab spanning thousands of square meters and measuring several meters in thickness. This dense block of reinforced concrete was designed to act as the primary structural distribution plate, taking the immense concentrated weight of the 60-story tower and spreading it across the modified soil beneath in a standard rock and cord high-rise project. This foundation mat is completely locked in place by vertical steel piles that descend deep into the earth, preventing any lateral or vertical shifting. But because Huaxia Genesis implemented the cheaper jet grouting method, this massive concrete raft was essentially floating on an artificial cushion of stabilized mud. The concrete pouring schedule was aggressive. In major Chinese metropolitan construction, speed is tied directly to financing cycles. Developer loans are structured around hitting rapid milestone targets, reaching the 10th floor, the 30th floor, and ultimately the topping out ceremony. Under intense pressure from corporate headquarters in Shanghai, the general contractor pushed the concrete crews through relentless 24-hour casting cycles. Thousands of cubic meters of fluid concrete were pumped into the core walls week after week, and with every single cubic meter poured, the physical mass pressing down on that stabilized mud mattress increased exponentially. Then came the year 2018. The structural skeleton had successfully climbed past the 40th floor. That is when the municipal construction inspectors and on-site layout surveyors noticed the first serious anomaly during a routine vertical alignment audit. Graphic fly-in. The plumb line deflection chart. Basement layer, 0 mm. 20 th floor, 22 mm north. 40 th floor, 58 mm north, 76 m north. The laser levels did not lie. The building's central elevator core was drifting away from its theoretical vertical axis. The initial logs revealed that the northern edge of the foundation slab had experienced an unexpected differential settlement of exactly 76 millimeters, because the north side of the base had dropped lower than the south side. The entire 204-meter concrete spine was leaning like a giant lever toward the river. The general contractor immediately halted the structural assembly of the next floor plate to run an emergency diagnostic. They brought in specialized digital tilt meters and precision optical sensors, mounting them directly to the primary load-bearing columns. The data confirmed their worst fears. The settlement was active. The building was not just leaning, it was actively sinking unevenly under its own dead load. This was the exact moment where standard engineering protocols demanded an immediate, total shutdown of the site. The correct, professional response would have been to freeze all vertical progress, secure the structure, and immediately begin an expensive, high-pressure underpinning operation, drilling emergency micropiles through the existing basement floor all the way down to bedrock to stabilize the sinking northern quadrant. But underpinning is a financial disaster for a private developer. It requires specialized equipment, takes months of meticulous, slow-speed drilling, and completely destroys the project's profit margins. Instead of pausing to fix the underground failure, an alternate engineering directive was issued to the site crews. They were told to implement a geometric correction vector on the remaining unpoured floors, 3D showing the compensation valves, concrete formwork, shifted south by a fraction of a degree per floor narrator. If you look closely at the structural design files from late 2018, you can see the madness written directly into the concrete dimensions. For every new floor poured above the 40th story, the wooden formwork used to retain the wet concrete was intentionally offset by a fraction of a degree to the south. The structural engineers were attempting to construct a counterweight lean. They believed that, by intentionally shifting the weight of the upper 20 floors in the opposite direction, the cumulative center of mass would exert a rotational force back onto the foundation raft, pressing down on the southern edge and balancing out the northern settlement. It was an incredibly high-stakes game of architectural seesaw played with millions of kilograms of reinforced concrete. But high-rise structural systems do not behave like ample wooden blocks. As the concrete crews poured these modified offset levels, they created massive, unengineered eccentric loads within the building's structural frame. The internal shear walls and vertical columns, which were designed to experience pure vertical axial compression, were suddenly subjected to immense, unintended bending moments and lateral shearing forces. The building did not balance out. The foundation mattress continued to settle unevenly on the north side, completely indifferent to the geometric gymnastics happening 60 stories above. By the time one Seaport Plaza reached its maximum height and topped out at 60 stories, the physical geometry of the building was a total disaster. The lower section of the tower tilted precariously to the north, while the upper section curved aggressively toward the south. The building had achieved its permanent structural banana shape. Sound effect, metallic twisting, and snap of wind gauge's narrator. In late 2019, a second, highly respected structural auditing firm was quietly retained by the project's financial backers to conduct an independent safety review. They installed advanced, continuous monitoring GPS sensors at the absolute summit of the 204-meter tower to track its structural behavior in real time. What they discovered sent shockwaves through the local housing bureau and the Municipal Construction Commission. The independent engineers compiled months of highly sensitive structural telemetry data, and their final report was damning. They revealed that the total lateral deflection at the top of the tower had actually worsened, expanding past the initial metrics to a stunning 101 millimeters of displacement. But it was a single written warning hidden inside that dossier, penned by a senior structural academic, that represents the most chilling detail in this entire timeline. The engineer noted that the top of the tower was continuing to move laterally long after all concrete pouring had ceased. This ongoing, unceasing movement indicated that the building was experiencing severe long-term creep behavior within the foundation soil. The modified mud mattress underground was continuing to deform and slowly flow outward under the sustained, crushing pressure of the tower. Text on screen. The ongoing lateral migration of the structural summit indicates that the foundation matrix has failed to reach a state of static equilibrium. long-term creep behavior remains highly active. Additional unpredictable structural movement will inevitably manifest as environmental and live loads are introduced to the frame, narrator. Do you understand what that means? It means the building was not dead. It was not stable. A skyscraper that is settled onto solid rock and stopped moving is a stable structure that can be safely measured, retrofitted, and built around. But a skyscraper that is still creeping, still shifting, and still tilting, years after the last bucket of concrete has cured, is an active hazard. It is a structure whose final structural geometry and ultimate stability nobody on Earth can accurately predict or guarantee. And while this silent underground crisis was escalating behind closed corporate doors, the chaotic reality on the outside of the building was about to force the entire disaster into the public eye. Make sure you are ready for part 3, where we examine how this bending tower fits into a much larger, systemic pattern of foundation failures across high-density coastal developments, and how these structural shortcuts are triggering multi-billion yuan legal standoffs across major financial districts. Click subscribe now, because document number 4 is about to crack wide open. Sound effect. Brief, elevator ping-clared over the ominous low-freak hum of a building can structurally under stress graphic. A massive high-resolution satellite archive map sliver showing Mule Tipple. Red blip markers along the coastline of the Yangtze River Delta, running from Shanghai down to Shenzhen and the Pearl River Delta. Text flash, Asian fault comparison make track narrator. To fully comprehend the structural crisis paralyzing One Seaport Plaza, you have to look outside this single square block of Shanghai. You have to realize that this bending, 204-meter concrete tower is not an isolated freak accident. It is part of a deep, systemic architectural vulnerability that has plagued high-density coastal megaprojects across mainland China's most volatile geological zones for over a decade. When you build at this immense vertical scale on soft, water-saturated land, the margin for engineering compromise is exactly zero. And yet, when we look across the construction archives, the exact same pattern of foundation cutting and uneven soil settlement reappears over and over again like a structural ghost in the machine. Image flips through archcove diagrams of coal mine, subsidence in the north and soft silt, compression in Mari. Time hubs narrator. Consider what happened during the rapid urban expansion phases in the Pearl River Delta, where massive luxury residential high-rises were pushed upward at breakneck speed on recently reclaimed maritime mudflats. Or look at the highly documented foundation crises in the northern megacity of Tianjin, where immense commercial towers built on deep alluvial plains experienced sudden unexpected differential settlements that forced immediate, multi-million yuan emergency stabilization interventions. Even look at the legendary structural anomalies that shook the tech hub of Shenzhen, where super-tall towers began to experience unexplained, high-frequency structural vibrations that sent office workers fleeing into the streets. In almost every single instance, the root cause traces directly back to the interface between the structural base and the earth, where developers pushed the limits of soil physics to minimize capital expenditure and accelerate completion schedules. But what makes the One Seaport file uniquely catastrophic is how those structural compromises interacted with the building's extreme height-to-width ratio. 3D render overlay animation showing the effects of toon winds exerting massive kinetic force on a leaning tower, acting as a lever narrator. In structural engineering, a tower's slenderness ratio determines how it responds to lateral environmental forces. One Seaport Plaza is an incredibly narrow, slender residential tower. It was designed to pierce the sky like a thin, elegant needle along the riverfront. But when a slender building is anchored to a compromised, uneven foundation, every single metric of structural resistance flips upside down. When a typical, wide-base commercial tower suffers a minor differential settlement, the internal loads can sometimes be redistributed across a broader network of heavy core columns. But with a hyper-slender needle tower like One Seaport, the entire structure acts as a massive mechanical lever. Every millimeter of settlement at the basement level translates into centimeters of horizontal displacement at the 60th floor and out on the Shanghai waterfront. That horizontal displacement immediately collides with a terrifying meteorological reality, the typhoon season, sound effect, a deep, simulated roar of wind tunnel texting meters maxing out into the red critical zone narrator. Every high-rise designed for the Shanghai financial district must undergo rigorous aerodynamic wind tunnel testing. They are engineered to withstand the brutal, sustained kinetic forces of Category 4 and Category 5 typhoons rolling inward from the East China Sea. To survive these immense lateral forces, tall buildings are designed to flex. They are meant to sway slightly under wind load, absorbing the kinetic energy and dissipating it safely through internal dampening systems. One seaport plaza was engineered to include an advanced structural stabilization system at its summit, heavy liquid slosh dampers, and tuned mass stabilizers, Desai, GNEND to counteract the building's natural sway and minimize acceleration forces on the upper residential levels. But because of the escalating structural crisis between the developer and the construction crews, those critical stabilization systems were never fully installed or calibrated on the upper floors. Visum close-up computer simulation showing uninspected reinforced concrete shear walls torquing under twisting force narrator. Think about the absolute insanity of this physical scenario. You have a 204-meter reinforced concrete skeleton that is already permanently out of plumb, leaning sharply to the north and warped like a banana to the south. Because it is permanently bent, the building is under constant, massive internal structural pre-stress. The concrete shear walls on one side are locked in extreme tension, while the columns on the opposite side are buried in intense compression. And now, you take this compromised, pre-stressed, unbalanced concrete spine. You leave it completely unfinished and exposed to the raw element currents off the Huangpi River, and you completely strip away the internal dampening systems designed to control its motion. For years, this building has been standing on the skyline completely naked against the wind. Every time a major storm cell hits the financial district, the tower sways violently, torquing and twisting along its deformed axis. With no internal dampers to arrest the kinetic oscillations, the structural joints are subjected to millions of cycles of fatigue loading that they were never modeled to withstand. Sound effect, the sharp, piercing snap of high-strength accordion bolts under metallic shear narrator, and this continuous, unmitigated swaying under extreme structural pre-stress is exactly why the exterior facade began to experience a visible, terrifying physical failure. The prefabricated steel anchor brackets holding the glass curtain wall to the floor slabs were under constant, unexpected shearing forces due to the building's permanent curve. As the tower flexed back and forth in the river winds, the misaligned anchors began to distort. The glass panels didn't just stop fitting. They were actively being squeezed and twisted by the movement of the concrete frame. Under immense localized stress, the high-strength perimeter seals began to fail, and massive sheets of heavy exterior glazing began to detach from the building's face. The Municipal Housing Bureau and Safety Commissions had no choice but to intervene. The site wasn't just a financial dispute or a quiet engineering debate anymore. It had evolved into an active vertical hazard zone, drops away from one of the busiest, highest-density urban riverwalks in the world. If you want to understand the human cost of this engineering compromise, the story of the workers trapped inside this warping structure, the panic of the 71 wealthy families who watched their life fortunes freeze inside a concrete shell, and the massive multi-party legal warfare that has locked this disaster in place, you need to step directly into Part 4, hit subscribe, turn on notifications, and get ready. The human timeline of the one seaport catastrophe is next. Sound effect, a heavy, metallic thud clanging eco-consciously in an enclosed space, slowly transitioning into the systematic ticking of a metronome graphic. A documentary-style timeline sober with corporate stamps and Red Law Bureau seals. Text flash, site safari logs and liquidators narrator. Behind every multi-million yuan engineering disaster, behind every structural calculation that fails on a corporate spreadsheet, there is a human timeline. A timeline written in the sweat of the high-rise construction crews who are forced to pour concrete inside a warping structure, and in the sheer financial panic of ordinary people who watch their life savings dissolve into a useless, bending cage of reinforced steel. To fully understand the rot at One Seaport Plaza, we have to look past the macrometrics of soil settlement and step directly onto the active concrete decks during the height of the construction frenzy. We have to look at what happens when a developer prioritizes speed and structural shortcuts over the literal survival of the human beings on the payroll. Visual dramatic reenactment. Graphic showing a sévère weather warning over the waterfront. The metronome speed increasing narrator. The year was 2017. The structural lean was already actively developing deep within the foundation mattress, but it was still being kept strictly confidential by the executives at Huaxia Genesis Property Group. Up on the active construction decks, high above the river, the pressure to maintain the rapid casting schedule was absolute. The site was operating under a grueling, high-intensity shift system, forcing crews to work through blinding coastal rain and slick, high-altitude winds. On one of those chaotic nights, a veteran concrete worker named Zhang Wei was stationed on the exposed edge of the 29th floor. The safety infrastructure on the site was already under immense strain. Because the building's concrete columns were beginning to drift out of plumb, the temporary safety netting and structural perimeter guards were misaligned. Gaps were forming between the wooden scaffolding arrays and the shifting concrete edge, as Zhang Wei attempted to guide a heavy concrete delivery tube into the floor forms under low visibility conditions. A sudden, unmitigated wind gust ripped across the exposed deck. With the perimeter safety anchors improperly secured due to the structural twisting of the slab edge, there was nothing to catch him. Zhang Wei plunged from the 29th floor, falling straight down onto the lower mechanical staging platform. He died instantly. Sound effect, distant reverberating industrial, siren, slowly fading into an intense courtroom, silence. Narrator. The local municipal safety bureau and the district fire rescue teams rushed to lock down the site. The subsequent investigative audit uncovered a horrifying web of systemic safety violations. The specialized concrete subcontractor, a major high-rise engineering firm called Shanghai Construction, was found to have systematically cut corners on structural scaffolding protocols, worker harness tie-offs, and edge protection integrity to meet the developer's brutal speed targets. The fallout was immediate and devastating. In a landmark ruling by the local People's Court, Shanghai Construction pleaded guilty to criminal negligence and corporate manslaughter in connection with the systemic safety failures on the project. The court ordered massive financial restitution to the victim's family and levied heavy, punitive fines against the firm's executive board. The Municipal Construction Commission issued an immediate, total stop work order. For months, the crane sat dead in the sky. The wind howled through the hollow, unclad concrete frame of the 29th floor, but for Huaxia Genesis, the clock was ticking. Every single day, the project sat frozen. The interest on their multi-hundred million yuan development loans was compounding. The moment the safety suspension was lifted, instead of fundamentally re-evaluating the building's shifting equilibrium, they pushed the new general contractor to double down on vertical progress. And that is when the engineering cover-up collided directly with the financial elite of the region. Graphic. Computer screen graphic deplacering luxury apartment brochures with pristine renderings of balconies overlooking the waterfront. Text stamped across. Combined deposits forfeit. 850 million plus narrator. Remember, One Seaport Plaza wasn't just a commercial block. It was marketed as the ultimate ultra-luxury sanctuary for Shanghai's top-tier tech entrepreneurs, finance executives, and old-money industrialists. The marketing campaign was flawless. Private elevator access, custom Italian marble interiors, floor-to-ceiling smart glass panels, and uninhibited 180-degree views of the historic riverfront. 80 premium units were offered during the pre-sale phase, trusting the pristine reputation of the global structural engineering consultants and the premium marketing materials. 71 wealthy buyers signed binding acquisition contracts. Deposits were wired into escrow accounts, ranging from tens of millions of yuan for standard mid-tier suites to astronomical sums for the multi-story sky penthouses. These families weren't just buying square footage, They were investing their multi-generational capital into a physical legacy asset. Instead, they bought a front-row seat to a multi-billion yuan corporate civil war. Sound effect. Excerpt sound of multiple law papers being ripped open. Rustling text effect narrator. By 2019, the secret of the structural banana could no longer be contained behind corporate non-disclosure agreements. The primary general contractor, realizing that the structural deformation on the tower was worsening with every millimeter of foundation creep, initiated a massive preemptive lawsuit against the developer. Huaxia Genesis, the legal filing was an absolute bombshell. The contractor stated plainly on the record that the entire 204-meter skyscraper was actively leaning over 76 millimeters to the north due to an unengineered, unstable foundation decision made long before they inherited the site. They argued that the structural integrity of the frame was compromised, making it fundamentally unsafe for the construction crews to continue working on the upper decks and completely uninhabitable for any future residents. They wanted out of the contract, and they wanted their financial losses covered in full. The response from Huaxia Genesis was furious and immediate. They fired back in the local media, calling the contractor's structural claims patently false from start to finish, and dismissing the entire lawsuit as nothing more than malicious corporate defamation designed to cover up the contractor's own operational delays. They admitted there was a minor alignment cosmetic variation on the upper levels, but insisted that their secondary engineering consultants had deemed the site completely structurally sound to settle the escalating corporate warfare. The project's major state-backed banking lenders demanded a comprehensive structural audit from an independent authority, the China Academy of Building Research-style expert panel. They brought in an elite team of senior forensic structural engineers to physically map every square centimeter of the concrete frame. Their findings completely obliterated the developer's public relations campaign. Visual flips to a Kulakad heat map of the skyscraper showing severy in structural strain, concentrated around the center bend narrator. The expert panel discovered that the structural deformation was actually far worse than what was reported in the contractor's initial lawsuit. According to their precision telemetry, the cumulative tilt had progressed to a shocking 101 millimeters before the massive weight of interior finishes, heavy marble floors, glass walls, and resident furniture had even been placed inside the structure. One of the lead forensic engineers on the panel issued a chilling, written brief to the municipal authorities. He stated that the ongoing lateral migration of the 60th floor, long after the structural topping out phase had concluded, proved that the long-term creep of the jet-grouted soil mattress was highly active and entirely unpredictable. He warned that if construction proceeded without an immediate, total foundation overhaul, the introduction of additional weight would accelerate the uneven settlement, potentially driving the building's internal shear walls past their ultimate structural limit. This warning was the final nail in the project's coffin. It meant nobody could guarantee where this building would stop moving. It meant one seaport plaza was a multi-thousand-ton concrete question mark floating on mud. Sound effect, heavy slam of a gavel companioned by a low extended bass reverb narrator. The general contractor packed up their tools, pulled their workers off the decks, and completely walked away from the site. Huaxia Genesis, desperate to maintain appearances, brought in a secondary lower-tier construction company called Ray Engineering to try and salvage the exterior. Ray Engineering spent months attempting to completely redesign the aluminum tracks of the glass curtain wall, trying to manufacture custom, angled brackets that could somehow conform to the building's permanent banana-shaped curve. It was a useless exercise in futility. By the summer of 2020, the physical realities of the distortion became unmanageable. Large sections of the newly installed glass curtain wall had to be stripped off the facade entirely because the twisting concrete frame was putting so much pressure on the glass that panels were on the verge of fracturing. All progress on the exterior ground to absolute, permanent halt. Today, 71 elite families are locked in a devastating legal limbo. Their multi-million yuan deposits are completely frozen inside a bankrupt, winding corporate entity. They cannot move in. They cannot get their money back, and they are left staring up from the riverwalk at a hollow, decaying concrete shell that represents the total liquidation of their family wealth. But the true danger of One Seaport Plaza isn't just the financial ruin of its buyers. It is what happens next to a 204-meter bending tower that has been left completely abandoned to the elements. Get ready for Part 5, the final chapter of this file. We are looking at the terrifying future scenarios for this structure, the astronomical 9-figure cost of a potential fix, and the absolute engineering logistics of demolishing a 60-story concrete monolith in the most crowded financial center in the country. Click subscribe now. The finale is coming up. Sound effect, a deep metallic reverberation tone that slowly fades into the distant, systematic sound of traffic and rumpled water graphic. A high-contrast satellite photo of the Shanghai financial waterfront. A red circle encircles One Seaport Plaza, with multiple expanding concentric cells radial from the base. Text flashes, Urban Danger Radius Zones narrator. We have reached the final chapter of the One Seaport Plaza file. The structural chronology is clear, the engineering blunders are fully documented, and the human cost has been completely laid bare. But now, we have to look directly at the most terrifying question of all. What happens next to a 204-meter, 60-story concrete banana that is frozen in a state of active structural deformation in the middle of one of mainland China's most densely populated financial districts? As of the most recent reporting from the Municipal Housing Bureau and Coastal Eye infrastructure monitors, the current physical state of the building remains completely unchanged. The structure is still standing, still entirely hollow, still leaning, and still permanently bent. It has become a massive vertical monument to boardroom compromise, completely tied up in an endless, agonizing web of multi-party lawsuits between Huaxia Genesis Property Group, the corporate lenders, the former general contractors, and the 71 wealthy families whose life savings remain trapped inside the concrete shell. Sound effect, the low, drumming pulse of Tiphoon Wien Gog's returning narrator. But while the legal papers sit piled high in the local courts, the physical structure continues to face the laws of gravity and materials science every single second of the day. Multiple independent structural engineers and geotechnical specialists consulted on the project have reached a unanimous, devastating conclusion. There are only two possible paths forward for One Seaport Plaza, and both of them are unprecedented architectural nightmares. The first option is a complete deep foundation structural rehabilitation. To arrest the active settlement and pull the building's center of gravity back into a safe static state, engineers would have to perform a massive underpinning operation. This would involve executing high-pressure drilling through the existing basement mat slab to install hundreds of high-strength steel micropiles deep through the soft river silt, anchoring them directly into the bedrock 15 meters down, 3D mortal animation. Showing the complex, high-pressure micropiling extraction process under the foundation slab narrator once those piles are locked into solid rock. A massive network of synchronized hydraulic jacks would have to be installed beneath the primary load-bearing columns. Engineers would then attempt to slowly lift the sunken northern quadrant of the multi-thousand-ton tower, millimeter by millimeter, to stabilize the baseline. But according to recent municipal reporting on the project's financial feasibility, the cost of an underpinning operation at this vertical scale would easily reach a staggering 9 figures in yuan. We are talking about a minimum of 700 million yuan just to fix the foundation of a building whose entire planned condominium sellout value was only 1.9 billion yuan. And even if a consortium of banks agreed to fund this massive operation, it would still not fix the core structural deformity of the tower. Remember, the upper 30 floors were constructed deliberately angled in the opposite direction. If you jack the foundation back to a perfectly level plane, the bottom of the building becomes straight, but the top half will now tilt sharply to the south. The permanent banana curve is baked into the high-strength concrete core walls and floor slabs. It cannot be unbent. Suffect, a sharp, distant volley of controlled explosion imitations, Ascent by heavy industrial drum drops narrator, because a genuine structural repair is both financially ruinous and geometrically impossible. Multiple observers, including leading structural academics from the municipal design institutes, have stated plainly that the only realistic, safe path forward is full, total demolition. But think about the logistical insanity of demolishing a 60-story, 204-meter reinforced concrete tower in the dense, high-value financial district of a global megacity. You cannot simply use controlled implosions or precision explosives on this site. One Seaport Plaza sits on a tiny, hyper-congested urban footprint, located just 2 blocks from the edge of the river and surrounded by multi-billion yuan commercial skyscrapers, high-speed underground transit lines, and heavy municipal utility corridors. An explosive implosion would send massive seismic shockwaves through the soft river silt, potentially destabilizing the sensitive, driven pile foundations of every neighboring tower in the district. The risk of triggering a catastrophic domino effect underground is far too high. That means the entire 60-story concrete monolith would have to be disassembled manually, piece by piece. From the top, down visual zoom, a simulated blueprint timeline showing mechanical cranes systematically cutting concrete decks hundreds of meters in the air narrator. Crews would have to install massive, high-altitude structural scaffolding cages around the summit of the tower. Heavy mechanical diamond wire saws and concrete pulverizers would have to be lifted to the 60th floor to systematically cut the reinforced concrete floor plates, shear walls, and core columns into small, manageable blocks. These blocks would then have to be carefully lowered down via specialized exterior hoist systems, floor by floor, working backward through the entire 5-year construction cycle. It is an incredibly slow, high-risk, multi-year industrial undertaking that would cost hundreds of millions of yuan, and currently, neither the bankrupt developer, the state-backed lenders, nor the municipal government has agreed to foot the massive bill, so the tower stands. It remains frozen on the skyline, transitioning into a dark, permanent symbol of what happens when the relentless pursuit of rapid real estate returns overrides the fundamental laws of geotechnical engineering. Sound effect, a slow, ominous music decrescendo underlining a calm, analytical concealing narration narrator, the entire catastrophe of One Seaport Plaza, the structural lean, the permanent banana curve, the detached glass facade, the tragic death of Zhang Wei, the criminal manslaughter convictions, the financial ruin of 71 families, and a 204-meter tower that may have to be systematically demolished before a single person ever spends a night inside. All of it flows directly back to a single boardroom decision made before the ground was ever broken. The original geotechnical engine, earring recommendation existed. It was fully drafted on paper. It was the correct immutable answer, and it was completely available to the developers before construction started. It told them to drive piles to bedrock. It told them that if they spent the capital to anchor the tower to solid rock, the structural settlement of the project would be absolutely zero. They ignored the paper to save 42 million yuan on a 1.9 billion yuan development. They saved a mere 2.2% on the upfront foundation budget, and the ultimate cost of that 2.2% discount was the entire skyscraper. The One Seaport Plaza file is officially closed. If you want to follow how these identical patterns of structural cutting continue to manifest across the global construction files, and if you want to be here the exact minute document number 5 opens, click that